All right, guys, what's up? Welcome to 5.2, and we're going to be learning about something called Pythagorean triples. So it has to do something with the Pythagorean theorem, but we're going to be looking at something that is going to be something called a Pythagorean triple. And we're also going to be looking at the Pythagorean theorem and its converse, meaning proving if a triangle is going to be a right triangle or not. That's what we're going to look at. So let's jump into that. So the first thing we're going to look at is what I mean by a Pythagorean triple. So any three sides that truly measure into Pythagorean theorem, I mean, if I plug them into Pythagorean theorem and it makes it true, that's going to be a Pythagorean triple, and it has to be whole numbers. So if I was to plug, though, these are two well-known Pythagorean triples that you should go ahead and memorize. A 3, 4, 5 right triangle is known as the Pythagorean triple because 3 times 3 is 9, 4 times 4 is going to be 16. 16 and 9 would make 25. 5 times 5 is 25. So 25 and 25 equal each other. Okay. Same thing with this one, a 5, 12, and 13. If I plug this into Pythagorean theorem, it would then make the Pythagorean theorem true. So these are well-known Pythagorean triples because they mainly work with each other. And so how we're going to use these will be put down in our examples here in a second. I'll show you. Okay. The next thing we're going to look at is the Pythagorean converse. So that means if I give you three side lengths, can you tell me what type of triangle it makes? And we're going to use that by plugging it into Pythagorean theorem. So if I plug three side lengths, so if I have A, B, and C, and I plug those into Pythagorean theorem, and it's equal, that means it's going to be a right triangle. It means it does satisfy the Pythagorean theorem, okay? If I plug it in, and my hypotenuse squared is less than a squared plus b squared, then that means it's not a right triangle. It means it's an acute triangle, okay? If the hypotenuse side is bigger than a squared plus b squared, then that means it's going to create an obtuse triangle. So these are going to be the formulas you're going to use today to prove if it's a right triangle, an acute triangle, or an obtuse triangle. Okay, so we're going to put that into play. So let's jump into our examples. Okay, so let's go ahead and look at this real quick. So on this example, I need to find the value of x. So yes, ladies and gentlemen, if you wanted to, you could just use Pythagorean theorem and get done with this. Okay, but I'm going to use a Pythagorean triple, but you have to think of it as if it's being factored up or down, meaning I'm multiplying each one of those numbers to get a bigger number, okay? So let's go ahead and think about this. So I've been given a 3, 4, 5 right triangle, 3, 4, 5 right triangle, right? Well, if I look here, 3 is a factor of 6, 4 is a factor of 8. So 3 times 2 gave me 6, 4 times 2 gives me 8, right? So 3, 4, 5. Well, I multiplied times 2 to get 6. I multiplied times 2 to get 8. So if I multiply 5 times 2, that'll end up giving me 10. So I literally just took the 3, 4, 5 Pythagorean triple and I scaled it up by 2. I multiplied times 2 on everything, and that scaled it up. So that's a way that you can use a Pythagorean triple. If you can recognize that pattern and see it's just, hey, the 3, 4, 5 scaled up by that much, I don't have to use Pythagorean theorem. I can just use a shortcut and find that it equals 10 there, okay? Let's do it on our next one. Okay, so on our next one here, I know I've been given two Pythagorean triples, a 3, 4, 5 and a 5, 12, 13. Well, if I look here, a 5, 12, and 13, well, 5 is a factor of 15, so 3 times 5 would end up giving me 15, okay? And then 13 is a factor of 39 because that's my hypotenuse, which is also going to be times 3. So I know 12 is going to go here, so 5 times 3 gives me 15, 13 times 3 gives me 39, and 12 times 3 is going to end up giving me 36. So again, I used the Pythagorean triple of 5, 12, and 13, and I literally just scaled it up by 3. And that gives me a Pythagorean triple that's the same. So I used the Pythagorean triple and figured out, oh, it's just scaled down to 5, 12, 13, and then I scaled it back up to find what 12 was, or my x value was, okay? So that is using a Pythagorean triple. I could just use Pythagorean theorem if I wanted to find that, like in the last lesson, but I'm just using a shortcut here. So Pythagorean triples, okay? Okay, so on the next one, it says determine if each set of lengths can form a right triangle. So I'm literally just seeing if it will form a right triangle or not. So let's go ahead and check this out. So I have 5, 5, and 10. So all I have to do to figure out if it makes a right triangle is by plugging these into Pythagorean theorem. So a squared plus b squared equals c squared. So remember, my longest leg is always the hypotenuse. So I'm going to do 5 squared plus 5 squared is equal to 10 squared. So 5 times 5 is 25. 5 times 5 is 25. 10 times 10 is 100. 25 and 25 is going to give me 50. And does that equal 100? It does not. So that means this is a no. It is not a right triangle. Okay? Let's go ahead and check out my next one. So I've been given 3 side lengths, and I need to figure out if it forms a right triangle or not. So again, I'm going to use a squared plus b squared equals c squared, right? Remember, your c value is always the longest leg. So this is my longest leg, so I got to plug that in for the c. The other two, it doesn't matter if I plug it into a or b. So here we go. So 10 squared plus 24 squared is equal to 26 squared, okay? So 10 times 10 is 100. 24 times 24, I don't know what that is. So 24 squared is going to give me 576. And then 26 squared is going to end up giving me 676. 100 plus 576 is going to equal 676. So since they are equal to each other, that checks out. So that's going to be a big fat yes on this one. It does form a right triangle because it satisfies the Pythagorean theorem. Okay? Let's jump over to our last example on number 4. Okay, so now on number 4, it's taking it a step further. I have to determine what type of triangle this is. So I have to figure out if it's obtuse, acute, or right. Okay, so here we go. So it says determine if each set of lengths is obtuse, acute, or a right triangle. So again, I'm going to use Pythagorean theorem. So remember, my longest leg is always your c value. So I'm going to do 4 squared plus 6 squared equals 7 squared. So this is going to be 16 plus 36 is equal to 49, okay? And then 16 plus 36 is actually going to end up giving me 52. And so right now, if we look, 52 is going to be greater than 49. So if my A and B add up to be more than my hypotenuse, that means this is going to be an acute triangle. So that means this guy is a acute triangle because the A and B is bigger than the 49, okay? So now I'm going to do the same thing with the next one. So again, my biggest side is always your c value. So I'm going to do 12 squared plus 35 squared is equal to 37 squared. So 12 squared is going to be 144. 35 squared is going to be 1,225. And then 37 squared is going to be 1,369, 1,369. So if I add 1,225 to 144, that's going to come out to be 1,369. So does 1,369 equal 1,369? I think it does. So this is going to be a right triangle because it satisfies the Pythagorean theorem, okay? Now let's do the last one. Again, this is my longest side, so that has to be my c value. So 5 squared plus 2 squared equals 6 squared, right? 5 times 5 is 25. 2 times 2 is 4. 6 times 6 is 36. So 25 and 24 give me 29. 29 is going to be less than 36. So if the hypotenuse is bigger than a squared and b squared, that means this is going to be an obtuse triangle, okay? All right, so ladies and gentlemen, what you're going to do now is you're going to take the information about the Pythagorean triples and you're going to take the information about figuring out if it's a right triangle or not, and you're going to take that into your skill check and work it for me. If you have questions, let me know on Schoology. If not, you got a teacher in the classroom that can help you out. Take it easy.
Tell me what you need. Tell me what you need. Tell me.